Okay, so you guys have really outdone yourselves this time. A whole video script on how to set up a test environment. I mean, it's dense,
Yeah, it's a pretty deep dive,
yeah,
literally. But it's important stuff, even if it sounds like something only developers would care about.
right? Because we've all been there.
Yeah.
You're using some software and it just crashes or freezes or does something completely unexpected.
And that's often a sign that, well, maybe the testing process wasn't as thorough as it could have been.
Exactly. So we're going to unpack this whole test environment thing. No jargon, just the core knowledge.
The goal is to help everyone understand why these environments are so important, what they're made of, and how they're managed.
So, let's start with the basics. The script defines a test environment as basically a controlled setting where software gets tested before it's released.
Right, and that word controlled is key here. We're not talking about just randomly clicking around and hoping for the best.
It's about replicating as closely as possible the real-world conditions that the software will be used in, right?
Exactly. It's like a dress rehearsal before the big opening night. You want to catch any potential problems early on.
Makes total sense. Because fixing bugs after the software is already out there, that's going to be a lot more expensive and a lot more disruptive.
Yeah, think about it. Imagine a banking app crashing because of a bug that could have been caught during testing. That's a huge problem.
Not just for the bank, but for all the users who rely on that app. So these test environments are really about risk mitigation.
Exactly. It's about proactively preventing problems rather than reacting to them after they've already occurred. And your script breaks it down into four main types of test environments, which is a really useful framework.
So first, you've got the development environment. That's where the initial coding happens and the very basic unit testing.
Right, very early stage. Then you move on to the testing environment. That's where more comprehensive functional and system testing takes place.
Okay, so that's where things get more rigorous. Then there's the staging or pre-production environment. This one is really interesting.
Yeah, staging is all about mirroring the live production environment as closely as possible. It's the final checkpoint before release.
So if everything works perfectly in staging, you can be fairly confident it'll work in production, right?
Exactly. And finally, you have the production environment, which is the live system that users interact with.
Okay, so those are the four main stages, each with a specific role to play in ensuring quality.
And it's important to note that each environment has different requirements in terms of hardware, software, and data.
Right, so let's talk about those key components. First up, you've got hardware and infrastructure.
Yeah, this is all about the physical servers, the storage systems, the network setup. It all needs to closely resemble the production environment.
The script even mentions this big decision, cloud-based versus on-premise solutions.
Right, and that's a trade-off between flexibility, cost, and control. Cloud is great for scaling quickly. On-premise gives you more direct control.
But the key is, regardless of which you choose, it needs to accurately reflect the production environment's capacity and performance.
Exactly, you want to be testing under realistic conditions. Okay, next up we have software and application configurations.
Right? This is all the software involved. Operating systems, databases, APIs, all those things. And they all need to be the right versions.
Oh yeah, version control is crucial here. Imagine testing on one version of a database and then deploying on another. That could be disastrous.
That's about compatibility issues. So meticulous tracking and management of all software configurations is absolutely essential.
No question about it. And then there's test data management, which is something people might not immediately think of, but it's super important.
The script really emphasizes the need for realistic test data. You can't get meaningful results if you're testing with data that's completely artificial.
Right, it's like trying to simulate a car crash using toy cars. It just doesn't give you an accurate picture.
And it even mentions using anonymized production data, which makes sense. You get the realism without compromising user privacy.
And they also talk about synthetic data, which can be useful for testing very specific edge cases or scenarios that are hard to replicate with real data.
Okay, so now we're getting to the fun stuff. Test tool and automation frameworks. This is where we see those cool automated tests in action.
Yeah, tools like Selenium and Appium, which are great for simulating user interactions on websites and apps.
And you've got tools like Postman for testing APIs and JMeter for load testing to see how the software performs under stress.
And of course, CI/CD pipelines. Think Jenkins and GitHub Actions. These are like automated assembly lines for your software.
So the code is constantly being built, tested, and deployed in a really streamlined fashion.
And this allows for much more frequent and comprehensive testing than would be possible manually, which means catching bugs earlier.
Makes sense. And finally, we have security and access control. No compromises here.
Absolutely. Test environments often contain sensitive data, especially if you're using anonymized production data.
So the script emphasizes role-based permissions. So only authorized personnel have access to specific parts of the environment.
And firewalls, VPNs, encryption, all those things are crucial to protecting sensitive data.
Because a security breach in a test environment could have just as serious consequences as a breach in the production environment.
Exactly. So when you put it all together, you've got a pretty complex system, but a very necessary one.
Right, because all these components working together is what ultimately leads to accurate testing and higher quality software.
And that brings us to the best practices for actually setting up and managing these environments.
Right. How do we make sure they're running smoothly and effectively?
Yeah.
The first one is defining clear test environment requirements.
Sounds simple, but it's crucial. You need to document everything. Hardware and software requirements, access permissions, version numbers.
It's all about clarity and avoiding ambiguity. Everyone on the team needs to be on the same page.
Exactly. Then there's implementing infrastructure as code, or IAC. This is where you use code to define and manage your entire environment.
The script mentions tools like Terraform, Ansible, and Kubernetes. It's like having a blueprint for your infrastructure.
And that means less room for manual errors, more consistency, and easier replication of environments.
Okay, so next we have using virtualization and containerization. This is where things get really flexible.
Yeah, think virtual machines, Docker, Kubernetes. They allow you to spin up and tear down isolated test environments very quickly.
And that's super useful for running multiple tests in parallel without them interfering with each other.
And for rapidly deploying and testing new code changes. Then you have automating test environment provisioning.
This is all about using scripts to automate the setup process, so it's not all manual, which can be time-consuming and error-prone.
Right. Automation is key for efficiency and consistency. And of course, there's regular monitoring and maintenance.
You need to keep an eye on things like system logs, disk space, CPU usage, basically make sure everything is running smoothly.
And proactively address any potential issues before they become major problems. Then there's keeping test environments isolated.
Right. This means keeping your QA, staging, and production environments separate. Prevents conflicts and accidental changes.
Imagine a developer accidentally deploying code to the production environment because they were working in the wrong environment. Not good.
Talk about a disaster.
Mm.
And then, of course, there's version control and configuration management.
This ensures that you can track changes to your environments, roll back to previous configurations, and maintain consistency.
Tools like Git and SVN are essential for this. And finally, there's establishing clear communication among teams.
Absolutely crucial. Developers, testers, DevOps, stakeholders, everyone needs to be in the loop to ensure the testing process runs smoothly.
Because when problems do arise, and they inevitably will, good communication is key to resolving them quickly.
Exactly. So those are the key best practices. And when you follow them, you end up with test environments that are stable, scalable, and dependable.
Which ultimately leads to better software for everyone.
Couldn't have said it better myself.
Well, this has been a fascinating deep dive. We've covered a lot of ground.
We've talked about the importance of test environments, the components that make them up, and the best practices for managing them.
And I think the key takeaway is that these environments are not just some technical detail.
They have a direct impact on the quality and reliability of the software we all use every day.
Exactly. And that brings me to a final thought for our listeners. Think about how these principles of testing and quality assurance might apply in your own field or area of interest.
It's about being proactive, planning ahead, and paying attention to detail. And that's relevant in so many aspects of life, not just software development.
Absolutely. And that's all the time we have for today. Thanks for joining us on the Deep Dive.
Until next time.